This section is called Solving Harder Quadratic Equations. So what we're going to do in this section is we're going to revisit what we did in Unit 6-7, Section D, where we looked at solving quadratic equations. Since we looked at that, we have learned a bunch of different techniques for factoring quadratics. So by the end of this lesson and the associated practice questions, we want to be able to solve a quadratic equation of the form ax squared plus bx plus c equals 0 by factoring using any of those strategies that we've learned in this entire unit. So first, let's refresh our memory on what we did when we were solving quadratic equations. We know that what we see here, x squared minus 8x plus 12 equals 0, is a quadratic equation. We know it's quadratic because of the x squared. And we know that in order to solve this, we want to factor it. We want to get this as two things multiplied together to equal 0, and then we can set each of those things equal to 0, solve for x, and then check if we need to. So we've done this one before. We are looking here. If we're going through our factoring strategies, first thing we would do is look to see if there is in fact a common factor to all these terms. So x squared, we just have a coefficient of 1 on the x squared, a negative 8 and a 12. There isn't anything common to all three of those terms. We see that it has three terms, so we are just going to factor this as a trinomial. And this is a simple trinomial because the coefficient on x squared is just 1. So we can factor this by looking for two numbers that multiply to 12, positive 12, and add to negative 8, that middle term. And these two numbers are going to be negative 2 and negative 6. Negative 2 plus negative 6 is negative 8. Negative 2 times negative 6 is positive 12. So our factored form is going to be x minus 2, x minus 6 equals 0. And then we set each of these factors equal to 0. By this point, you probably just do this step in your head. And we solve. X equals 2. X minus 6 equals 0. X is going to equal 6. And those are our two solutions. So now let's look at some examples where we use the other techniques of factoring. So the process is basically the same though. We want to write our equation as something times something else equals 0. Get it in that factored form. And that's going to involve, obviously, factoring. We're going to set each of our factors equal to 0, and then we're going to solve for x. So when we look at this one here, first we check to see if there's a common factor. Our coefficients are 3, 8, and 4. There's nothing common between each of those. We have three terms. This is a trinomial. Our a value out front here is 3, so it's not 1. So this is one we're going to have to factor using decomposition, or that AC method. So we take our a and our c and we multiply them together. That's 3 times 4 is 12. So we're looking for two numbers that multiply to 12 and add to that middle term, which is 8, and both of these are positive. I think our two numbers here are 6 and 2. 2 times 6 is 12, 2 plus 6 is 8. So we're going to use that 6 and that 2 to break up that middle term. So this is going to become 3x squared plus 6x plus 2x plus 4 equals 0. And then we are going to factor by grouping. We're going to group those terms together, these two terms together, and we're going to look for something that's common. So for our first two terms, we have a 3 that is common, and the x is common. So let's factor out that 3x, and we're left with x plus 2. 6 divided by 3 is 2. And then for our second two terms, 2 is going to be common. So we'll factor out a 2, and we're left with x plus 2, and this is still equal to 0. So this is good because we have the x plus 2 and the x plus 2 which match. So that is now common. Let's factor that out front. And we're left with the 3x plus 2 equals 0. So we've got it in we factored it, so we have it in our form something times something is equal to 0. To get our solutions, we're going to set each factor equal to 0 and solve for x. So the first one is pretty easy. X plus 2 equals 0. We've done this a lot. We're going to subtract 2 from both sides and get x is equal to negative 2. You can probably do that one in your head. The second factor is a little bit more complicated because we can see we have two numbers appearing in there. So one like this, it's probably a good idea to actually write it out, setting it equal to 0, and do your opposite operations. Subtract 2 from both sides to get -2, and then we're going to divide both sides by 3. X equals -2 over 3. And those are our two solutions. Okay, x equals -2, and x equals -2 over 3. So it's okay that that's a fraction. That's a valid solution to a quadratic equation. Okay. All right, let's take a look at some ones that use slightly different techniques. 4x squared minus 12x equals 0. Well, first thing we're going to do is we are going to look for a common factor between the two terms. So what is common first between the numbers, between the 4 and the 12? A 4 is definitely common because they're both divisible by 4. And in fact, x is common to both of these as well. So if we factor out 4x, we end up with x minus 3 equals 0. And this is now in fully factored form. We can't factor that thing inside the brackets anymore. So we have it in factored form as something times something equals 0. We're going to set each of our factors equal to 0. So 4x equals 0 and x minus 3 equals 0. And then we're going to solve both of these for x. 4x equals 0. If I divide both sides by 4, 0 divided by 4 is just 0. So x equals 0 is one of my solutions. And that's a perfectly valid solution to a quadratic equation. For the other one, if I add 3 here and add 3 here, I get x equals positive 3. So my two solutions are x equals positive 3 and x equals 0. Over here on the right, we've got x squared minus 121 equals 0. Let's see, first we would check to see if there's a common factor, but the coefficient on x squared is just 1, and there's no x in that second term, so there's no common factor. We have two terms here, so when I look at these two terms, I see that this first one here is x squared, and the second one is 11 squared, and they're subtracted, so this is a difference of squares. So this is going to factor to x minus 11, x plus 11 equals 0. And then again, we're going to take both of these factors and set them equal to 0. And we're going to solve for x. So here I'm going to have to add 11 to both sides. X equals 11. And here I'm going to subtract 11 from both sides. X equals negative 11. And those are going to be my two solutions. Here we have two quadratic equations that give us a little bit of a twist here. They're still quadratic equations because we still see the equal sign, we still see the x squared in both of them, but they're set up a little bit different than the other ones because instead of having something equal to 0, we have something on like an x or a number or something on both sides of the equal sign. Our first rule in tackling things like this is we know that we want this to be something times something equals 0. So before we do anything in terms of our steps here, we want to get this so that there is just 0 on that right-hand side. So what I'm going to do to this first one here is the thing that I have on the right-hand side is a -2, so I'm going to add 2 to both sides. If I add -2 and 2, I'm going to get 0. And if I add 2 on the left-hand side, I'll end up with x squared plus 3x plus 2. There's no common factor there. This is something that I recognize as a simple trinomial. So now I can factor this and get it into my factored form. So I want two numbers here that multiply to 2 and add to 3. Both of these are positive. Those numbers are going to be 1 and 2, both of them positive again. So I know I'm going to have my two factors. I'm going to have an x, and I'm going to put in that plus 1 and that plus 2. And then for my solutions, again, I'm going to set each factor equal to 0. I'm going to have x equals -1 and I'm going to have x equals -2. Something similar is going on in this second example over here. 3x squared equals 6x. My first step is going to be to get just a 0 on that right-hand side. So I'm going to have to subtract 6x from this side and subtract 6x from this side. That 3x squared and that minus 6x are not like terms. So I'm going to have 3x squared minus 6x equals 0. Now I move on to my factoring. What is common between these two terms here? 3 is definitely common. Both 3 and -6 are divisible by 3. And an x is common. So we can factor out a 3x. We'll be left with an x here. 3x times x is 3x squared. And here we'll be left with -2. And this is completely factored. That didn't take us very long. So we're going to take each of our factors and set them equal to 0. For 3x equals 0, I'm going to divide both sides by 3 to get x equals 0, because 0 divided by 3 is just 0. And here I'm going to add 2 to both sides, x equals +2. And there are my two solutions. So we'll do one last example here that uses a lot of the types of factoring, I think. We've got 4x squared minus 24x plus 32 equals 0. Let's look first for a common factor. Our common factor here is 4. Each of these is divisible by 4. So we're going to pull a 4 out front. We have x squared. Let's see, -24 divided by 4 is -6x. 32 divided by 4 is 8. So we've written this as 4 times x squared minus 6x plus 8. Now we want to factor this trinomial here that appears in the brackets. So how would we factor this? This is a simple trinomial. So we are looking for two numbers that multiply to +8 and add to -6. All right, those two numbers, it's going to involve 4 and 2, and I think they both have to be negative. -4 times -2 is +8. Negative times negative is positive, and if we add them, we get -6. So this is a simple trinomial. I'm going to keep the 4 out here. Like the 4 doesn't vanish. We still need that 4 there. I'm going to create my two brackets here, equals 0. So everything stays the same, except we're taking this bracket, this x squared minus 6x plus 8 in brackets, and we're factoring it. I'm going to need an x here and an x here. I'm going to need a -4, and I'm going to need a -2. So there it is in fully factored form. And in this case, I have 1, 2, 3 factors that are multiplying together to give me 0. The principle still applies. We want to take each of our factors and set them equal to 0. Now, when we take our first factor and set it equal to 0, 4 equals 0, this can never be true. 4 can never equal 0. So this factor doesn't provide us with a solution. So really, we can just ignore it. But our next one, x minus 4 equals 0. We're going to add 4 to both sides. X equals 4 is our solution. Our third term there, x minus 2, set it equal to 0. Add 2 to both sides. X is equal to +2. Okay? And just a reminder that these two solutions that we get, x equals 4 and x equals 2, we can identify these with the x-intercepts of the graph of the associated parabola. So over here on the right, I've got a graph of y equals 4x squared minus 24x plus 32. We can see our two x-intercepts here at 2 and 4. So these things are our x-intercepts.